Alright, pretty much through. Box problem. Cardboard sheet that measures 10 inches by 30 inches has its corners cut out and is folded up into an open box. Draw a diagram of this situation. So it's a rectangular sheet that is 10 by 30 inches, and it's having a corner cut out of, or I'm sorry, it's having a square cut out of each corner. So all of those should be perfect squares, and all of them should have a side length of x, like that. Boom, boom, boom. So if you think about what we're doing, we're being left with a shape that looks like this, to the best of my drawing abilities, which means we have a couple sides here that are missing pieces. So we should relabel them as this side, 30 minus 2x, because I've cut two x's out of the corner, right? There's one x, there's another x cut out. And then the other side should be 10 minus 2x, because again, I've cut out 10 there and 10 there, leaving that middle bit, which is 10 minus 2 times whatever x is. And then I have my corners, which I've labeled x, right? The little squares, those are the lengths I've cut out. And again, picture what we're doing though. We're taking this box and we're folding it up into a box like that. So there's my side x, here's a 30 minus 2x, and here's a 10 minus 2x right there. Alright, well, thoroughly drawn. And we want to find an equation for the volume of the box in terms of x. Well, volume of a box equals length times width times height. So x times 10 minus 2x times 30 minus 2x is the equation of my box in terms of x. What is the domain in the context of the problem? Well, think about the limiting factor. The limiting factor here is side length. Our shorter side length is 10, or in this instance, 10 minus 2x. So we need 10 minus 2x absolutely to be greater than 0, because you can't have a side length of 0. It doesn't make sense. And so 10 has to be greater than 2x, which means 5 has to be greater than x, which means x has to be less than 5. So our domain for x, we should probably say 0 is less than x is less than 5, right there. What corner cut size will maximize the volume, and what is the maximum volume? Well, now we need to graph that on our calculator. So go to y equals, enter it in exactly like you see in factored form. You don't need to expand it. X parentheses 10 minus 2x parentheses 30 minus 2x parentheses. Now go to your window. X min should be 0, X max should be 5, coming straight from our domain. Once you choose the realistic domain, hit zoom, fit option 0, it'll give you a perfect window. And once it finishes graphing, we can say second, calculate maximum is option 4. For left bound, we can hit 0. For right bound, we can hit 5. And then we can hit enter for guess, and it'll say that the maximum occurs when x equals 2.257. So what corner cut size will maximize the volume? Well, corner cut size of x equaling 2.257 inches. And what is the maximum volume? Well, the maximum volume is our y value, which is 315.565 inches cubed, because we're talking about volume.